In the words of a broken heart, it's just emotion that's taking me over. Tied up in sorrow, lost in my soul. But if you don't come back, come home to me, darling. You know that there'll be nobody left in this world to hold me tight. Nobody left in this world to kiss goodnight.
Alright, pretty much what I'm going to do now is pretty much, okay, so first of all we have a simple notification system, okay? We have a bunch of notifications which combine for a simple queuing system. Now once we have a simple queuing system, we obviously add it to the first in first out, so that's a usual queue, and we have a standard queue, so I'm just going to say ST, okay? So ST is obviously for standard queues, and simple queues for, what was it called? 1 second guys. Okay, so let me try to explain this again. A simple notification system, and we have SQS, which is obviously like for many of these notifications to be like put into a queue, and everything in the queue is basically all these notifications are interactions between these components, and each of these notifications are going to be added into a queue. And once it's added into a queue, it's pretty much just going to like sort of show you all the different notifications, and each of these notifications in this queue can be picked, processed, and then deleted. Okay. So then we have two types of queues. Okay. So we have the standard queue, which is obviously the difference is that this allows only up to 300, okay, 300 messages, except this one allows up to infinite amounts of like 300 messages per request, okay, I'll just say 300 messages per request, so 300 messages at a time. But in this case, it would pretty much just like group everything together. So using it would properly group things, but in this case, it won't group things at all. Okay, so the next thing we're gonna have, okay, so as you can see, order of messages is not guaranteed. So it's gonna give it a group ID. Okay, message order is assured based on the group ID. Okay, so everything's much more organized. So it's a simple queuing system. Workflow. So we have a step function. So all the work. So in a workflow, we have steps, individual steps. So it's step 1, step 2, step 3, step 4. All these different steps need to be executed in order. So that's what workflow step functions are. So individual steps in a workflow. Okay, so let's move on to the next one. do I have, okay, wait a minute. Is my microphone bugging? I'm not too sure if my microphone's bugging, but I don't think so. Okay, so pretty much, apart from that, so it uses, so to execute, once again, on Lambda itself, right? It pretty much executes all these tasks using step functions, okay? Tasks can handle all the work in step functions. So these are part of Lambda, okay? So Lambda functions or an API. So tasks using an activity, Lambda function, or an API to execute the code. Okay, activity is a software that you create and host on AWS on premises or on a mobile device. Okay, so that's interesting. So let me just get a note of this. Grab that real quick and let's paste this here. So it's a cloud and step function tasks. Okay. Let's move on. So step functions work in steps, obviously. Client polling. So this is when you have a so long running transactions. You're going to be having long running transactions, and all of these are going to be all using an ID. So we're going to be having a message ID for this, and then you can check with the message ID. So whenever you have a long running transaction, right? So obviously you need information from time to time because it's running for a long time. So you need to, when you initiate it, you get a message ID, and once you have a message ID, you can pretty much keep calling from it to understand what's going on within the application. It's so the extended version of this will be the X-ray, Amazon X-ray, where you can see the infrastructure, the whole what's happening behind the scenes for everything that's happening in the application. Okay, so pretty much this one, okay, synchronous flow is replaced easily because this is I'm assuming this is asynchronous, right? So let's see. Okay, so let's make some questions saying, is serverless client polling pattern asynchronous? Question mark. Okay, so now let's move on. And client polling method is a standard standard method for obtaining status information in on a long running transaction. So let me just do obtaining. There we go. Boom. Just like that. Okay. Computer's bugging again. SNS, it's obviously, you know, usual webhook pattern is with SNS. Okay. So we have two types of clients. We have trusted clients. Let me just close this for now. Trusted clients, and then we have untrusted clients. Okay, untrusted clients. So trusted clients are basically authorized, already known clients within the infrastructure which are authorized, right? Untrusted clients are when you have a public API gateway which could be allowing external traffic into the VPC, right? So what we're doing here is we pretty much have webhooks or HTTP callbacks that user defines, right? So pretty much a webhook is like a URL, okay? A callback is a function passed as an argument to another function, right? That's like usual. This is part of JS, I'm pretty sure. But anyways, what I need to tell you guys is when it comes to untrusted clients, so trustworthy and untrusted clients. Let's say, okay, so API gateway is obviously for request and response cycles. So it's a AG, okay, API gateway. And this sends a request, okay, sends a request. And first of all, we have a route 53, which is the DNS. So I'm just gonna call it R5, R53. Okay, R53 sends another request. So what R53 does is it gets the IP and all that, and then it sends it to CloudFront. Okay, CloudFront sends it to the load balancer. So I can zoom in here. I don't know why I can't zoom in here, but I don't know why I can't get here. Anyways, so let me just like grab this here, I guess, then it's much easier. Okay, so what we do next is CloudFront. Okay, so we're gonna call it CF. And CF pretty much sends okay, so once I have CloudFront, it sends it to the ELB, which is the Elastic Load Balancer. And the Elastic Load Balancer is the one that sends it to the Lambda gateway, which is part of the EC2. Okay, so EC2, and we will send the Lambda request. So it's a LAN. This will, inside this we have the Lambda functions. Okay, so Lambda will then communicate with the database within this VPC, and then once it communicates, it's going to send a response back. It's going to send Lambda's going to send a response back like this, and then like this, and then back to the user through the API gateway. Okay, so it's a request response cycle. Apart from that, we have messages and streams. So streams are strings of messages, and messages are individual messages. Messages don't have a high priority. Well, streams are going to be flowing in extreme high capacity, and then we're going to wait for, in case of a loss of strings of messages, we're going to wait and then retry, and then keep retrying until we get those messages, receive those messages back. So that's why you see in video games and stuff, you see like timeouts, right? Timeouts and connections, because we're waiting for messages to be received once again, right? So now let's move on. And so once again, we see step functions here, and let me just make sure everything's fine. Okay, so we're seeing step functions, and AppSync is obviously a GraphQL service. So it's a GraphQL service which automates the like real-time. It gives you real-time data analytics. So I'm just gonna call it GraphQL. Okay, so it's let me just go over here. I need a proper definition of this. Okay, let me go down here. Connection between a server and a backend. Sorry, client and a backend. Right here, backend server. Okay, so it's a request response cycle. That's what an API gateway is. Okay, so let's go on to API's AppSync, and we have a GraphQL service that offers real-time data synchronization. So obviously we have a subscription returns data, data update when it happens, right? So what we're gonna do is we see the GraphQL as a newer API than a standard REST API, right? It is getting more popular, so that's the more popular. It's the newer framework compared to a representative. What was it? The REST API stand for some state transfer, something like that. So basically, REST API is like, the usual HTTP get post put methods, the ones that we use to Postman and all. So we have a status update. I think it's a status update. Yeah, status updates. So when you subscribe, you can subscribe to status updates, so that way you can get, it's like a mail, you know what I mean? Mail, it's like a newsletter. So when you subscribe to it, you get notifications from it. So AppSync can automatically subscribe to status updates and offers offline development capabilities. Subscription returns data when it happens, and it is also called a real-time update. It is best suitable for data-driven applications. So we have real-time data sync. It's a GraphQL service that offers real-time data sync, which is what AppSync is. Okay. So now let's go on to claim check. Okay. So let's go on to claim check. So claim check has pre-signed URLs. So let me just draw this here. Pre-signed URLs, which are assigned to objects. Okay, so that's what so they're pretty much like checking. Okay, so let me has access to some object. So this has access to this object. That's the point of it. Okay, so pre-signed URL will use the AWS credentials of the user who created it. Right. So we're gonna say it will use. So that's certain important points. AWS credentials of the user who used it, who created it. Okay, so this would pretty much check with this. And then think of returning data or not. Okay, so in that case, it will let, if this is true, then it will let them access this object. Okay, so now let's move on to client users the URL to update the object. Exactly. So it's like a way of accessing it in a way. Okay, so we have what else? Payload is a JSON structure that contains data. Okay, an URL that has access to some object. Okay, access to some object right here. Okay, pre-signed URL right here. Let's go to data processing. So a stream, exactly, a stream is a high transfer of data, and a buffer, data buffer is a temporary data storage in memory. Okay, so it's a data buffer, so it's a data buffer. So I just call it data buff because this looks like I'm writing database. Data buffer, and it pretty much stores, so it's a temp. Okay, temporarily stores data in memory. Okay, so it's a mem. Yeah, that's what this is. Data buffer is a temporary data storage inside the memory, local memory, inside the memory while data is being moved. So when in a stream, okay, so it's a think of it like this is like a stream. Okay, so this is the stream, and then the data buffers pretty much temporarily store data in memory. Okay, so data buffer is a temporary data storage inside the memory while data is being moved. Okay. So in a stream. So let's look at this, for instance. Let me show you guys. So this is Kinesis. Okay, so data firehose and data streams. So the difference between firehose and streams is like streams is used for more complicated processes, and I'm pretty sure it's more manual in Kinesis streams versus the Kinesis firehose. So firehose is a little easier from what I've remembered. Let me see. Let me just double check. Simplifies again. So so firehose is obviously the simpler way of doing things. And as you can see, can only have one direction. It's supposed, so this is obviously a more complex and better way to do things for compared to like Firehose, but it depends on the type of application, right? Because of that might be more efficient for a more efficient solution for converting and storing data. Data streams allow you to write custom consumers. So consumer is a product that uses Kinesis data to perform tasks, operations, right? A program that uses Kinesis data to do tasks operations. Okay, so that's what a consumer is. So let me just take this. Say cloud consumer is a program that users can assist data to perform operations. Cool. Now let's move on to stream versus message. I think I've explained what this is, and you can see that for failures, you have to set up retries. So yeah, exactly. So if data is not delivered, if the message is not delivered, it's going to be sent after a retry. It's going to be sent directly to a dead letter queue. Okay. So the message is again in this case, as you can see, it keeps retrying. So that's what when you're streaming. Think of it like this: when you're streaming, like let's say on live streaming purposes and all. It's going to start retrying as soon as like it stops receiving messages. It's going to start retrying to connect back to these messages to receive more messages so that the stream gets back online. You know what I mean? So that's why it is a stream of messages is typically continuous, while an individual message is more of a basis where you have to set up retries and dead letter queues in order to prevent any problems, right? So I mean, mixed messages are being forgotten pretty easily, right? As you can see, right? Once a message is read, it is removed. Data is kept on the stream for a certain amount of time. That's what this is when it comes to streaming. Okay. The streams, continuous, data. What would they call this? Streams. Data buffers that don't care. Okay, so data buffers that don't care what the user would do with them. Okay. So let me just get it. Let me highlight certain parts that I need to refer to again. Data buffers that don't care what the users would do with them. Actions or data on the stream will remain for a certain duration before disappearing. They provide error handling. Table below shows the differences between streaming and messaging. Right, so for streaming, it's obviously a stream of messages. That's what this is. And for messaging, it's individual messages. And it can be removed, right? Once it's read, once a message has been read, it is removed, and that is kept on the stream for a certain amount of time because it's a streaming. It's like live streaming. Failures, you have to set up retries and dead letter queues. Okay, so message is retried until it succeeds or runs out of time. Okay, so now let's take this and let's put this here. Messages for data processing. Let's go on to failure management. CloudWatch alerts help you logs help you overcome failures in your code. For example, so we have the Lambda logging library, which will push when it has errors, you can push data from Lambda to the CloudWatch logs by using the Lambda logging library, which will then redirect the errors onto the CloudWatch logs, and then you can debug them from the CloudWatch logs. So CloudWatch logs help you overcome failures in your code. Okay, that's what this is. As you can see, right here, let me just double check with this. And a login library, once again, just like I said, CloudWatch logs collects and aggregates exactly. So every recorded log can help you overcome failures in your code. Type of error handling is determined by the service you utilize. Okay. So asynchronous and synchronous, we know what synchronous and synchronous is. Async is basically synchronous. Once it fails, the whole thing fails. Once it fails, it won't retry. Okay. The next thing, it moves on to the next thing. Okay. If it fails in the process, either the whole application crashes or it moves on to the next thing. Okay. Asynchronous processors wait for a certain thing to be done and then move on to the next thing. It retries up to between 0 to 2 times. Okay. So it can also have the capability of running other things simultaneously to a certain task that is performed in lifetime. Okay, so as you can see, we have function errors and call errors. So function errors are errors that happen within functions. Call errors are usually the call errors. For example, when you're calling an API, we have problems or calling a database or something like that. When we have problems with call errors, and if the call goes to the function, but the function fails to execute, it's a function error. So those are the two types of errors that we look for in synchronous and asynchronous events. Okay, so again, call function and call errors. Okay, so now let's move on to stream-based events. Error stream-based. So yeah, for this, right, a batch of data is a large amount of data. One second. I'm confused with something else. Give me a sec. Stream versus message. Data buffer. My bad. A data buffer is a cloud. A data buffer is a temporary storage. Is storing data storing data temporarily in memory. And what was this again? I think it was handling SQS. Batch of data right here. Okay, batch of data is a large amount of data. Just got blocks of you can insert for. Okay, so let me just grab this specifically. And batch of data is a large amount of data. Okay, so if Lambda encounters an issue while processing a batch of data, it will stop processing new data. Okay, so if Lambda encounters an issue while processing batch of data, stop processing new data. Okay, so discover block shards. What are block shards? Consider cross shards. Okay. This is data streams and DynamoDB data streams. Main sources could be right. Okay, matches the AWS records. Right. Okay. Oops. Okay, so pretty much how we are handling for stream-based events, and processing is idempotency is basically processing the same request multiple times. Same. Records, my bad. Sorry. So it's processing the same record multiple times. It's such a hard word to remember. Idempotence. I can't even pronounce it. Idempotency. Processing the same record multiple times. Okay. So idempotency. How can you remember words like that? It's like a specific word. On failure destinations, say place right when. So exactly. So a dead letter queue is also like a on failure destination, right? So all the data from Lambda execution. Okay, so let's go on to me double check. Okay, so let's say on failure destination where data is stored when Lambda functions. When functions. Function fails. Execution, right? Let me double check with this. Function fails. Right, okay. On failure destination. Let's say right here. Failed event destinations. Copy. We just paste this here. Cool. Now, SQS queues, SNS is a simple notification system, and SQS is obviously a queuing system, and Lambda functions obviously event-driven, and we have Fargate, which is obviously a containerization service. So Fargate and Lambda is obviously the serverless side of things. So Fargate is for containerized applications, and for Lambda is for event-driven applications, which means everything is executed in events, right? So let's go on to error handling SQS. So this is SQS with Lambda. Or on Lambda functions, you can specify a timeout. In SQS, you can define a visibility timeout. Interesting. So until it succeeds, until the queue reaches its limit, Lambda will keep retrying. Okay. So let's say, sorry, my bad. Let's say cloud Lambda will keep retrying either until it succeeds or it reaches the queue limit. Okay, so reaches its limit, like until the queue reaches its limit, right? Until the queue reaches its limit. Okay. So, okay, go to error summary. So this is a summary. Okay, so this is from the stuff that we looked at so far, right? So API gateway, 30-second timeout, requests are sent through Lambda, where they're queued and executed, right? Configured by retention period, right? SQS queue configured by the recipient. Okay, so we get a picture of this graph right here. So let me just cloud error handling summary by execution model. That's the graph right here. Failure steps. Let's see the step functions. So in steps, obviously, that's obvious. But there's something else here. So obviously, step functions provides try, catch, finally logic for known and unexpected faults, right? Okay, so try, okay. Yeah, were introduced as a method of visualizing and coordinating your workflow, right? So these are provided automatically. That's interesting. Provides try, catch logic, right? Okay. Use the amount of call retries and function for print steps, obviously, or introduces a method of visualizing and coordinating your workflow. Interesting. Step function for failure management. So let me just paste that here. I'm just hurrying through this because my brain is brain rot. Dead letter queue. So this is where messages that are not fully delivered are sent to dead letter queues, right? So it can be delivered successfully exactly in the simple notification system or simple queuing system, right? It is recommended to enable special dead letter queues for asynchronous Lambda functions. For each function, you must construct the you first construct the queue or SNS topic. It is because the Lambda function is configured as an event source, right? So let me just copy this description right here. I didn't get that properly, but let me. Okay, so what I'm gonna do here is probably it's a place where for messages that can be delivered successfully, right? So it is recommended to enable special dead letter queues for asynchronous Lambda functions. For each function, you must first construct the queue or SNS topic. It's because the Lambda function is configured as an event source. Interesting. Queue policy. Let me just read through this. I need to read through this part. Okay, so let me just copy, paste this here. That letter Q versus on SNS SQS source queue, versus on Lambda function. The letter Q on Lambda function. Let me copy this. To a dead letter Q. I mean, that's obvious though. Can't spell Q properly. There we go. Clear tracing, once again. Oh my god. Good at this. The destination is where exactly, so. X-rays obviously for 1 second. Let me just go from the back, give me a second. So this is the serverless application module development, right? So serverless application module development is what this is. And you use the guided command for the guided, so what's this? Specify the S3 bucket, you can use a variation of, right? So this is in the CLI. Right. Okay, so we have guided for interactive mode. SAM deployment interactive mode. Okay, so it's application development module. That's what it is, SAM. CI/CD for code deploy. So code deploy is obviously like where the code pipeline is automates the whole thing. Code deploy is where you could deploy. The code commit is where you commit. Deploy is where you deploy the application, and code pipeline is basically where it automates the whole thing. A CI/CD software release that software CI/CD pipeline can assist software release procedures and failure checks. I'm pretty sure that's what it is. Quality checks, my bad. Okay. Quality checks right here. Software release procedures and quality checks, which is for what a CI/CD pipeline it can assist you with. Development deployment strategies. So all at once, deploys everything fast. Canary is like second speed because it's a little more aware of checking with the errors and stuff. Linear is like for complex applications where like there could be like bigger problems. So if you want to check for sure, you need linear. Okay. So all at once, canary and linear. So sharing config data, environment variables are dynamic variables that keep changing in like behavior of your application. So it's like API keys and all, which can be stored in the key management service as well, like encrypted and in ciphertext format. So SL developer, this is the journey. So local testing and deployment. using, so you use CloudFormation for infrastructure as code, so you know, for deployment automation and stuff. So you give it a script, and it will automate the process of building, test, and everything when it comes to like the CI/CD pipeline. So it includes testing. Testing, you need to do it locally, but then it will check for like errors and stuff within the deployment process as well. So that's what logs are used for, you know, fixing any failures in that. So we have the serverless application deployment module, which is SAM over here. And what else do we have? This is for CloudFormation. It uses JSON or YAML, while what's it called? Terraform uses a custom scripting language for every type of cloud provider service. Okay. So this is basically a serverless application development module. That's what this is. 1 second. Right here, right? So serverless application development module. That's what. Okay. So deployment is process is transferring current application to a server. Cloud server, both the same thing. Deployment is transferring current application code to a server. That's what it is. Let's go on to CloudTrail. So everything is logged as a trails on CloudTrail, and let me just stop this. Services that help you watch serverless apps. Right. Okay. Sure. Centralized reporting. Automate responses to possible security risks. Change the status of your resources. Changes or comply to policies. Take action automatically. Right. Right. If the changes are right, okay. Okay. Resource configuration, AWS on. Single, okay. Right. So events and trails. Every log is logged as cloud event history. It allows you to browse and download historical events. It was what's the difference between a trail configuration that helps configuration enables the delivery of CloudTrail events. Enables the delivery of CloudTrail events. Okay. Cool. So X-Ray is obviously managing all your resources, sort of getting an X-ray of your whole application. So it shows you everything. Over here, API gateway and MSNS. Right. Okay. So on Lambda, API gateways and SSQS. Yeah, right. Let me just get this real quick. Queues versus let's say yeah. CloudTrail versus config. CloudTrail versus config. CloudTrail versus config. And X-ray active and so passive is obviously for just searches in real time. Examples in instrument incoming requests, write traces to X-ray, can be integrated with Lambda, API gateway, right? So there's a active, right? So passive instrumentation is obviously a request for instruments that another service has used, so it's obviously passed, and it can add information to traces, can be integrated with Lambda, API gateway, SNS, and SQS. So let me grab this real quick. Okay, so we have the what do you call it, CloudWatch metrics. So the like you set alerts and stuff. CloudWatch metrics, CloudWatch logs, and CloudWatch log insights. So server's application, the information I'm getting incorrect. Right. Every other application begins with CloudWatch, CloudWatch metrics, CloudWatch logs, CloudWatch insights. Right, okay. So let me just grab this. Okay, cool. User experience, custom experience metrics. That's for. So we have business metrics, customer experience metrics, and system metrics. System metrics. What else do we have? So Lambda logs. We have API gateway execution and access logs. So the access control list as well for the VPC, VPC entries. We have stateful, stateless, what do you call it? Stateful and stateless, which is stateful keeps state of who you are when you log in. And then stateless simply makes you log in every single time because it doesn't keep state of who you are. And access control lists, pretty much it checks with the access control list either way. So that's depending on that, it either denies or allows access. So Redis is Elasticcache for Redis, yep. So sure, key management system utilizing either AWS Manage or client, right? Key management service. Simple storage, so simple storage, what this is. Non-relational, so no relation. So it's not SQL. It's non-relational. Elasticcache for Redis, so it stores everything temporarily, especially like keys and stuff, using the KMS here. Optional encryption through AWS KMS, utilizing either. So this is for sensitive information like keys. Key management service. That's what we use here. Okay, so. Oh man. To secure your Lambda functions, use IAM. Oh my god, I can't speak. But so you use IAM for giving certain what do you call them? Certain access for resources. So identity access management for users, my bad. So remember that you're in charge of inputs and outputs. So much sun hitting my screen right now. Ugh. Okay, so the first step in protecting your data is by encrypting it. The reason for this for that is URL parameters like request path or query strings are not always encrypted. Converting data from plaintext to unreadable format, right? Ciphertext. You can use standard output logs. No risk exposing unencrypted, right? Sensitive data should be encrypted before processing to maintain end-to-end encryption. So avoid sending or storing unencrypted sensitive data in a TCP request path, query, script, or string. Remember that you are in charge, right? Secure Lambda functions, use IAM permissions. Secure Lambda functions, use IAM permissions with the rules and rules with limited scope. Create smaller functions that accomplish specific tasks and don't share IAM rules. Right, within the IAM configurations, right? IAM rules to give permissions between services, right? Different users. That way it doesn't get not everyone can access certain stuff. Self-securing, we have Cognito for authentication, and IAM and Lambda authorizes. What was the difference between these two? I need to refer to that. So we have Lambda. No, we have logs. No. We have Cognito, obviously. Authorizers. And Lambda, isn't it? Is it log? IAM, my bad. IAM, I forgot. Okay. Yeah. Yeah. No. Okay, so pretty much we have IAM, Cognito, and authorizers. So obviously, let me IAM, Cognito, and authorizers. Right, so this is like custom use cases for Lambda authorizers is for custom use cases, right? And this is for done for you type of things, like sign in and sign up type of services. Right. It's great suited for AWS. Right, so let me just grab this. Let's say cloud, limiting access to APIs. Right. Okay. Ah, man. I think I should probably stay like this for now. So what I'm gonna do here is let's say for example mm, 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 mm. Between Wait. What the fuck was that? So there we go. I think that's much better. So it's gone. Oh my god. Feels super weird right now. Alright. Target uses. So obviously this is target is for containerized applications, while lambda is for event-driven applications. Exactly. Under 15 minutes. Static workloads. Predictable consistent workload. Real-time data processing. Applications user automation. Oh. Lift and shift method. Yes, lift and shift. Yep. There we go. Can't see my screen. What? Uh. Right, so I think I need to go through this again. Source code pipeline, bro. My screen's like super. I wish I could show you. My screen's like super. I don't know. Super fucked up. I can't see anything because of the sunlight. It's like gotta be in like a specific angle for some reason. Unless I keep it on like this part of my screen, then I think it's easier. Can I get this one to this part of my screen? There we go. There we go. That's better. A little bit better. Quality checks. There we go. All good. Linear and all at once, and Canary. Canary is the middleman. Linear is the slowest one for best quality checks, and all at once is the fastest, but no quality checks whatsoever, so it's bad for good applications. Uh, changing item, dynamically changeable item that changes the way dynamic variable, dynamic something item that can change how a program functions. Ooh, operates. Works. It operates, right? Behaves. Variable. Item. Named item. Are you serious? I don't even know named. That can change, but it's basically an API key value pair. You can change the API key and get the whole application to work with another, a whole different user. Color trail. This is burst behavior. Burst behavior is like when it's pushed to the maximum limits. The lambda functions. Lambda functions operate at the maximum limits. It's burst behavior, and also this is a function error. Age record, retry attempts, failure destinations, and scaling function step functions. Activity worker between components, communicating between services to receive tasks. That's what it is. I already had this, I think. Yeah. I have it. Yep. Okay. Right. Okay. So is it 0 to 1 to, so it's like three attempts total. So the 0th attempt is like the first attempt, second attempt, and third attempt. So Lambda will try it 3 times to process the event. If it keeps failing 3 times, so it's between 0 to 2, it will send it to a dead letter queue. And then we'll retry again in 7 days. The maximum of 7 days, right? Let me just grab this real quick. Let me grab like a thing. Yep. Okay. What? Request. I just forgot what I was just looking at. That's crazy. But anyways, let me just copy this part. And let me just... It's the best practice for event-driven separated applications. Tracing headers may be retrieved, used, and propagated using the trace ID. Be retrieved and propagated using the trace ID. Received and propagated using the trace ID. Retrieved and propagated, retrieved. SDK provides data incoming for about incoming algorithm requests to the X-ray and matches to the X-ray. The X-ray receives data from services as segments. X-ray receives data, services as segments, organizes them into traces. Right. Data tracing. Okay, so let's move on from here. For now, I'm just gonna dip for now, and I'll come back. But anyways, these are the notes. If you guys want to take a look at it, let me just grab this real quick. So these are the notes as of right now. Pause if you want to, take a snapshot. But these are so Aurora is a relational database part of the AWS ecosystem, and different metrics. These are under there's monitoring serverless apps. Cool.